Hello everyone, welcome to this video series on clinical SAS TFL programming. In this video, we will take a look at the lesson which is related to getting descriptive statistics for a single numeric variable. This video is part of table programming general concepts series. So we will now go to the background which is related to TFL programming. In clinical trials, the participants are randomly allocated to either test drug or a comparator group. So we will have different groups of subjects based on the number of treatments or treatment combinations being studied in the trial. So in a parallel arm study, a subject will only receive the treatment to which he or she is randomized to in the entire course of the study. So to assess if the subject characteristics are similar across different treatment groups, we create summary reports. Subject characteristics can be of numeric type, say for example, age, baseline BMI, etc., or of categorical type, for example, sex, race, etc. For numeric or continuous variables, the data is summarized in terms of sample size, number of records with missing data, mean or average, standard deviation, quartiles that is Q1, Q2, Q3, minimum and maximum values seen in the data, etc. These descriptive statistics are obtained for each group so that a comparison can be made between the groups. Below is a table summarizing the age value, and the results are presented in a tabular format with different treatment groups side by side for easy comparison. So we have this table title which is saying descriptive statistics for age variable based on a subset of subjects which is called as full analysis set. In this, the variable age in years is being summarized, and this is summarized in terms of n and missing, mean, standard deviation, median, quartile 1, quartile 3, minimum value and maximum value. And these values are being produced for subjects who are present in dose level 1 and subjects who are present in dose level 2, dose level 3, and a total column which is a combination of all the values seen across these three different treatment groups. So this is our total column. So some of the points to note in this kind of summary table. So we need to know the variable that is being analyzed, and that variable is generally called as an analysis variable. In the above example, age is being summarized, so age is considered as the analysis variable. The variable which contains the treatment group information is called a grouping or a class variable, or it can be even called a bivariable. In the above example, we are creating a summary to compare different dose levels. So the variable that contains the dose level of a subject will be called a class variable, or it can be even called a grouping variable or a bivariable. So if we are following Adam standard, the planned or actual treatment variables will be used as class variables. So for example, the planned treatment for period 1 will be present in a variable called TRT01P, and the actual treatment for period 1 will be present in a variable called TRT01A. So if we are following Adam standard, the grouping variables will be our treatment variables. So the next thing that we need to do is we need to check the different descriptive statistics that are being presented. We have already seen that the age is being summarized in terms of these all statistics. So in this example, n, missing, mean, standard deviation, Q1, median, Q3, minimum and maximum are being presented. And the next thing to note is the number of decimal values presented for different statistics. Say here if you see, the number of decimals for mean is to be displayed as 1 decimal, whereas for standard deviation it is represented with the 2x values, which means that we need to present the statistic for SD up to 2 decimals. Similarly, for median we have 1 decimal. For min and max we have only integers. XX is present without any decimal places. So which means we need to present the min and max values as integers. Generally, mean, median, Q1, Q3 will be presented up to one additional decimal place than in data, which means, say for example, if age is collected in integers, we need to present one additional decimal, which is one decimal for mean, median, Q1 and Q3. And if we have one decimal in data for age variable, we need to present mean, median, Q1 and Q3 to two decimals because we are supposed to present one additional decimal than in data. So this is a general rule. This can vary from one study to other as well. And then minimum and maximum values will be presented to the same number of decimals as in data. And standard deviation will be presented to two additional decimal places than in data. Some of the And again, the additional point that we need to note is that some of the statistics are presented side by side. Say for example, N and missing are being presented side by side. Mean and SD are being presented side by side. Q1, Q3 are presented side by side. Similarly, min and max. So treatment groups are presented as columns in the table. So and statistics are presented as rows in the table with a specific order. We are concatenating different statistics and we are also have a fixed order for those concatenated statistics such that the have make a meaning in the when someone is reviewing the data. So how do we program this in SAS? So there are multiple ways in which descriptive statistics for numeric variables can be obtained in SAS. The most commonly used procedures for this purpose are proc means or proc summary. Both proc means and proc summary can produce output to the output window or to an output data set. We need extensive transformations on the obtained numbers reported by these procedures. So, for example, we need to control the number of decimals to be presented for different statistics, concatenate two different statistics into a single row, and use descriptive labels for these statistics. So, we cannot use the output generated in the output window for these customizations. So we will be interested in fetching the statistics to an output data set and then process the data using a combination of data step, proc steps like sort, transpose, report, etc. to produce the final output. We will now take a look at the final report that we get out of this lesson. So if you see, we are going to generate a table which looks like this. So if you see, the statistics are being presented as rows and across different treatment levels. So with those level 1, 2, 3 and a total. So let us take a look at the input data that we will be using for this lesson and then try to manually identify some of the statistics for different treatment groups. So we have our ADSL data which has around 5 rows in which there are treatments corresponding to dose level 1. So there is one row for dose level 1 and 4 rows for dose level 3. So but if we have seen in the output, we were supposed to generate the report for dose level 1, 2 and 3, but we do not have any subjects in dose level 2. So we are presenting here, if you take a look at the report, so we are presenting it as 0 because we did not have any subjects in that dose level. So one subject in dose level 1 and 4 subjects in dose level 3, and our analysis variable is age, which is, and if you see again here, there are 4 rows with data available and 1 row with missing data. And then our grouping variable or class variable in this case is our planned treatment, which is TRT01PN or TRT01P. So analysis variable is age, grouping variable is either of TRT01PN and TRT01P because these are one-to-one relationship variables. And then were supposed to create this report based on a subset of subjects who were belonging to full analysis set. So we have that variable which is called FASFL. So all of the subjects have this FASFL is equal to Y populated, so which is equivalent to all the rows will be used for our report. Now let us switch back to our routine approach of filling in the form output data using the input data sets manually. So we'll try to identify the n and missing statistic and also min and max because other variables are derived variables. So it involves some calculations, but min and max are the values which are directly from the data. So we'll try to identify this. So we'll go with N and missing for treatment 1 first. So treatment 1 here is nothing but our dose level 1. So N statistic is the number of subjects with available data for age variable in that treatment. So dose level 1, number of subjects with non-missing data in age variable. So let us go to our input data set and then try to filter for dose level 1. So we have one record with a age value, which means a small n would be 1. So missing is the opposite of small n, so which is number of rows with a missing value in age variable with treatment 1. So we have seen that there was only one record with dose level 1 and that had age value present. So out of the one record there was no records available with a missing value in age. So this would become 0. Now let us try to populate the min and max for the same treatment of dose level 1. As there was only one record, the minimum value would be the same number which is present on that. So why I populated with 23? It is because we only had one row and the value in that age variable was 23. So what would be the minimum value in the one observed 23 is 23 and the maximum value will also be 23. Now let us try to populate the n and missing for TRT2. So we have seen that in the input data set we had only those records of level 1 and level 3. We did not have any records for dose level 3. So for that reason we will have to populate this with 0 and again a 0 for missing as well. So as we have the small n itself as 0, none of the statistics will have a meaning. So min and max cannot be populated. Now let us try to populate the n and missing for treatment 3. Now let us go to our input data and then try to filter for dose level 3. So we now have 4 rows and small n represents the number of rows with non-missing age value. Out of these 4 rows, only 3 rows had age value populated. So the small n value for dose level 3 for age variable is 3. How many records were there in the input data with a missing value in age? Out of these 4, 1 had missing. So the missing statistic would become 1 here. So now let us try to populate the min and max for dose level 3. So we had our data filtered. So we had values 35, 54 and 68. The minimum value is 35 and the maximum value is 68. So we will be populating it with those numbers 35 and 68. So similarly, let's try to populate it for total column. So TRT4 is nothing but our total column across these 4 values. So TRT4 is nothing but our total. So let's go back and then try to remove all the filters. So out of all the 5 available rows, so we had 4 rows with non-missing age values and 1 row with missing age value. So the statistics would become 4 and 1 here. And then minimum and maximum. So instead of going to the input data set, what I'm trying to do here is, so we now have identified the minimum value across all 3 treatment groups here. So the minimum value in the total would be the minimum across these 3 values. So what is the minimum across the 3 treatment groups or dose levels? It is 23. So 23 will be the minimum value across all 3 treatment groups. And what is the maximum value across 3 treatment dose levels? So it is 68. So the maximum value in the total column would be 68. So similarly, we can populate these derived or calculated statistics using the standard mathematical or statistical formulas. Now let us move to the programming that is being used to generate this final output. So here we have our program. So we were asked to generate the table based on the subjects who were in full analysis set. So I am subsetting only those subjects who were part of that analysis set using a where statement. And then I am processing. So we had in the report that along with the three dose levels, we had to present the total column as well. So for that, what I'm trying to do here is outputting the regular records and then outputting the record with a treatment value of total. So here I am creating a variable called treatment and using the values in plan treatment variable numeric and creating this variable. Similarly, I am creating another variable called treatment C and using the values in TRT01P variable into that variable. And then I am outputting the row and then assigning a value of 4 to that treatment. So along with those three treatment, I am creating one additional row for each subject so that the subject gets counted under total column. So we'll now see how our ADSL01 looks. So all subjects who were present in ADSL had FASFL is equal to Y. So when I subsetted for FASFL is equal to Y, I'll still get the same. So in the next step, I replicated the rows for each of the subjects so that I can count the subject under total column. So I had 5 rows in ADSL01. I am replicating each row and with a value of total in the treatment C variable and 4 in the treatment. So I'm using one TRT01PN in the first instance when I outputted the record. I am using a value of 4 for treatment variable and total in the treatment C variable. So this subject is now replicated for total column so that when I get the statistics, this subject will be counted under dose level 1 and also under total. Similarly, when this subject is being processed using treatment variable, so when this subject will get counted under dose level 3 and also get counted under total. So I am replicating the rows so that each subject gets counted under total and also under each dose level in which they were part of. Now let's move back to the program and then see what is being done. So we have seen that in the report. So we had three dose levels have to be reported, but there were no subjects in dose level 2. So, but we still had to get that number reported with 0 and 0 along with the total column. So for this purpose of creating a dummy column or column with 0 counts even for the dose levels who were supposed to be present in the data but do not have data yet, or so for that purpose what we are trying to do here is creating this format which has all the 4 levels. So treatment 1 for dose level 1, 2 for dose level 2, 3 for dose level 3 and 4 for total column. So I have created this format to use it in the downstream processing with all the 4 possible treatments column that I have to present in the report. And then I am using proc summary to create or to get the descriptive statistics. So here on the proc summary, I am specifying that ADSL02 has to be used as input, and along with that I have used two options, NWay and complete types, and I have used class statement. On the class statement I am specifying my classification variable, so which is treatment. And then on the where statement, we need to specify the analysis variable. In our example, age is the analysis variable. So I am specifying it on the where statement. And then I am using output statement to create a data set called stat01 by getting all the descriptive statistics. So we needed n missing, mean, standard deviation, minimum, Q1, median, Q3, max. So I am requesting all these statistics and I am using an option called auto name on this output statement so that I want all the statistics which are being created to be named automatically. So if we do not use the auto name, we need to specify the names of the variables that we need to store the statistics for age variable into each of the statistic name. And then here I'm using format treatment dot. So two things to note here is the usage of complete types and the preload FMT. So what preload FMT does when we use it on the class statement is, so if we do not use preload FMT, it will only create a summary for the levels which are present in data. So in the input data set ADSL02, which we are passing into the proc summary, we only have dose level 1 total and dose level 3. So 1, 3 and 4 were present. So if we do not use that preload FMT along with the format, so what happens is proc summary generates a summary for only those levels which are present in data, which is 1, 3 and 4. But for our reporting purposes, we also need that dose level 2 to be reported with a value of 0. For that purpose, what we are trying to do was we were creating a format which contains all 4 possible levels, and then we are specifying that treatment variable needs to use the format which is created, and this has all 4 levels. So, and we are specifying that all 4 levels have to be preloaded. So instead of giving a summary for only those levels which are present in the data, we are forcing proc summary to give a summary for each of the levels present in the format. And then we are using complete types, which is again going with this format and all the classification variables specified in the formatted treatment variable. So we'll get a data set named stat01 out of this proc summary. Now let us take a look at the output data set that is getting created out of stat01. So here if we see, so we had our classification variable, the summary is being produced at each treatment. One row is being created for each classification variable. So 1, 2, 3 and 4. If we had not used the concept of format treatment and preload FMT, this row 2 would not have been created because this level 2 is not present in data. So now let's take a look at the statistics that are being generated. So age underscore n, age underscore n miss, age underscore mean, and we are getting a variable for each of the requested statistic. So as we have used the auto name option, what it was trying to do is it has named all the statistics with a prefix of age underscore, which is our analysis variable. If our analysis variable was, say for example, BMI. So when we use the auto name variable, it would use that prefix of BMI underscore when creating the variables in the output data set. So if we do not use the auto name option, we can specify the names of the statistics on the after each statistic keyword which we are using here. So we can actually give the names manually here without using auto name. So now let us come back to the code and see what we have done in the next step. So we were processing all the statistics with the required concatenation. So we were supposed to concatenate. So it was it n and n miss. So in order for the concatenations to happen, so what we are trying to do here is create those individual statistics in character values, because we cannot concatenate two statistics when they are in numeric format, because the statistics that we get out of proc means or proc summary as of numeric type, and they have different more number of decimal places. So we are handling that here using the appropriate number of decimals using put function, and then converting them into character values, and then concatenating those individual statistics into combined statistics as per the presentation requirement. So we were presenting n and missing statistic in a single row, so we are concatenating those two into a single variable called n and miss, and then we were concatenating mean and standard deviation here to present mean and standard deviation together on a single row. And then Q1, Q3 are concatenated, min and max are concatenated into a single row. Now let us take a look at stat02 dataset to see how the concatenations were happening. So we have created individual character variables first, and then use those individual character variables as part of the concatenated variable. So we have created a variable called n and miss to concatenate both n and missing statistic. So we have concatenated mean and standard deviation. Median, there was no concatenation was needed. For Q1, Q3 we have concatenated those two, and for min and max also we have concatenated those statistics into a single variable. And then, so in our report, we had to present these statistics as rows, but we now have these as columns. So in the next step, we will do that processing. So here what I have done is created a separate data set to keep only the required variables. We don't need, as we no longer need that individual statistics and the numeric versions of the statistics, I just kept only the required concatenated statistics along with the classification variable. So let us take a look at the stats03 dataset. So it is nothing but a copy of stats02 but with only a limited set of variables which are newly created and have to be used in the program. So here we need treatment variable, which is nothing but our classification variable and the concatenated stats. But next step is that we need to transpose or restructure this data set such that these statistics are appearing as rows. So let us now go to the code and see how we have achieved that. So we are restructuring the statistics such that they are appearing as rows using proc transpose. So here we are using the values of treatments to stay as rows by specifying it on the by statement and then transposing the variables and miss, mean, standard deviation, median, Q1, Q3. Now let us take a look at the stat04 dataset and see how the dataset got transposed. So if you now see, so we have now NMIS, mean, standard deviation, median, Q1, Q3, min, max. These are all appearing as rows. This is how we need to present the statistics in the report. So if you see, the statistics are to be presented as rows. Now we have fetched those things as rows, but we need an additional transpose and creation of some labeling columns. So we will do that in the next steps. So in the next step, we are creating some additional grouping variables and labeling columns. So here we have to present in the report the label as age underscore years. So we have created a variable called age group label and assign the text of age underscore years. And then we were supposed to present the statistic in a specific text format. So we are now making use of this variable values. So n and miss, whenever this is n and miss, so we are converting that into n missing within the parentheses. At the same time, we need to present these rows in a specific order. So what we are trying to do here is create that internal order variable so that we can make use of this so that the statistics are organized in the uh, as in the shell requirement. And then now let us take a look at stat05 dataset. All we have done here is assigned this group variable and assigned a value of 1, and in the group label we have assigned the text of age underscore years, and then we have created this descriptive text that in the same way as how it has to be presented in the shell. So n missing, mean st whenever it is mean std. So median q1 q3 we have used q1 comma q3, and for min max we have used the text as min comma max in the proper case as per the shell requirement. So now let us move back to the code and see what we have done next. So here in stat05 we still had treatments appearing as rows, but we need these treatment columns to be appearing as treatment values to be appearing as columns. So for that we need to restructure this data again. So for that we can make use of transpose step, and then here in this proc transpose what we are trying to do here is use group label int order as statistics on the by statement and transposing the values present in column variable by specifying the treatment variable on id statement. Now let us take a look at stat06. One other thing to note is that we have used prefix is equal to option to with a value of trt on that. So we'll now see how that gets translated into. So stat06. So we see now that the treatment values are now appearing as columns. As we have used prefix is equal to trt, the values in treatment variable were 1, 2, 3, 4. So it prefixed the value of trt for the newly created columns. So 1 has become TRT1, 2 has become TRT2, and 3 has become TRT3, and 4 in treatment variable has become TRT4. So this is how we can make use of prefix variable, prefix option on proc transpose to name the newly created columns. So now this dataset looks much closer to the report that we need to generate. So we use this dataset to create the report which we were supposed to create. So for that we can make use of, so again I have created a temporary data set called final by keeping only the required variables. So let us also take a look at that final data set that was created, which only has the variables required for reporting. So and then we need to write proc report to create the report. So here I am assigning titles as in the shell, descriptive statistics for a single numeric variable age, title 2 with full analysis set, and then some color coding for this description, my csg.in as the third header, and then I have a footnote 2 which says st is equal to standard deviation, and then I am routing my output to RTF file by using ODS RTF statement, and then used proc report, and then I am making use of column statement to specify which all columns have to be used either as order or non-printable columns, or to be column other columns which have to be displayed. So in future lessons I'll cover extensively on how to write proc reports, so but I'm not going through in depth. So here I have used group variable for ordering, and I have used it as a non-printable column, and similarly int order variable which has that order for statistic, as this need not be printed, but we have to sort the records based on the values present in this variable. We have defined it as order but not printing, non-printable column. And then group label is being printed with a cell width of 1.5 inches, and then statistic column is being printed with a column header of statistic, and then treatment 1 column is being printed with a column label of dose level 1, similarly TRT2 with dose level 2, TRT3 with dose level 3, and TRT4 with total. And all those 4 columns I have used a width of 1.2 inches for each of the treatment columns, and I have used an option called just is equal to center so that the numbers get aligned in the center. So again, if we also have other options like justify based on the decimals or left justify the numbers, so we can make use of those options, but that will be exclusively covered in detailed sessions in proc report in future videos. So this is how we can generate a descriptive statistics table for a single numeric variable, but this same concept can be reused for how many number of numeric variables you may have in the report. So thank you for watching. Keep learning.